Welcome to the Airlock IAM 8.3 release video. I am Mark, and together with Mike, I'm going to talk about the most important new features of Airlock IAM 8.3. In this video, we're going to discuss the shown features. The video has chapter markers, so you can easily jump to the desired topic of interest. We'll start the video with presenting a few new Airlock 2FA related features, including cooldown period and one device. Then Mike is going to discuss OAuth 2 and OpenID Connect related features. He then presents a few scriptable flow step showcases. After going through new features regarding event notifications, we'll present some various new features and end the video with giving some general information about the release. The multi-number challenge feature is a new feature for the one-touch login. The one-touch login sends a push message to the user's phone, and the user has to accept or decline the login attempt on the phone. The goal of this new feature is to mitigate MFA fatigue attacks. It does this like shown in the following example. During the one-touch login, the user is presented with a screen in the browser like this one. It asks the user to approve the login request on the Airlock 2FA app and this is the new part, select the displayed number to log in. Here, in this example, the number 30 is displayed. Now, the user has to accept or decline the login on the phone as it was before, but in the next screen, and this is the new one, the user also has to select the number matching the number displayed in the browser. This feature has to be enabled in the future A service settings, so you don't have to do anything in the Airlock IAM configuration. It requires the latest Airlock 2FA app or an app using an SDK supporting this feature. The push to all feature is also a one-touch feature. In cases where a user has multiple devices, for example, several mobile phones or mobile phones and a tablet and so on, the user used to be asked to which device a push message should be sent. Now it is possible, if configured, to send a push message to all devices simultaneously. In some use cases, this is better than asking the user to select a device. The new feature is available for login flows, so authentication flows, but also in all approval steps, so especially also in transaction approval. The feature is enabled in the respective step, so for example in the Airlock 2FA authentication step or in any of the approval steps. The trusted session binding feature is a new security feature for Airlock 2FA. It is used where IAM is not really involved in some processes, especially in activation, especially activation from a letter, from a QR code letter, or in recovery. The idea is to add more security by tying these actions to an authentication flow that is controlled by Airlock IAM. It increases security and reduces some risks. It has to be noted that it only works for custom apps using the Future SDKs. It isn't supported by the Airlock 2FA app. The reason for this is because the app needs to call the IAM flow REST APIs. The feature works like this. So on the left side, you see a business app, for example, an e-banking app using the SDK. And on the right side, there is Airlock IAM. So in this example, we're going to show how to enroll the app using a QR code letter, but only for users that were able to authenticate themselves before enrolling. So the app just starts an authentication flow that has been set up for this purpose. And after the authentication flow, Airlock IAM knows which user it is about and asks the app for the activation code. So the app asks the user to scan the QR code from the letter and sends the activation code to Airlock IAM. Airlock IAM can now verify if the activation code was really issued for that specific user, the user that just authenticated. If this is the case, Airlock IAM gets a binding token from the Future A backend and sends it to the app. The app can then use the binding token together with the activation code to do the enrollment, and the Future A service will verify whether the activation code and the binding token belong together, and only then the enrollment can be successfully finished. The trusted session binding feature can be enabled in the Airlock 2FA settings. This is very easy, but you have to set up an authentication flow with the right steps in it. How to do this? We document it in the Airlock IAM documentation in the Airlock 2FA part. This is also possible for recovery, as mentioned, and it is also possible outside of authentication flows in the protected service flows. In the Airlock admin app, within the user management in the Airlock 2FA tab, the open enrollments or activations are shown. The new feature is that these open enrollments can be deleted as long as they are not yet used. So you see the new button on the bottom of the screenshot where the help desk could delete an open enrollment. Of course, this is also available as a REST API call. The user must have a special permission. It's called delete authentication token. And if the permission is not given, the button will not be available or the REST call will fail. There are situations where you want to migrate from one app to another app. For example, from an Airlock 2FA app to an own Airlock 2FA-like app, or if you follow a one-app strategy, from Airlock 2FA to a business app, including the authentication part. If you already have a lot of customers on the old app you want to migrate away from, it's not too obvious how to do this. So to make this easier, we added some new steps, and we also added a new documentation in 8.2 and in 8.3 that gives you the options and tells you exactly how to do this. So check out the new documentation within the Airlock 2FA part of our documentation. Last but not least, I would like to mention that we are going to publish an update for the Airlock 2FA app end of September or beginning of October 2024. And I would like to mention a few selected features. So the Airlock 2FA app, it now also supports username-less QR login. The feature was introduced into Airlock IAM in 8.2, but was only available for apps based on the latest SDK, but not in the Airlock 2FA app. So now you can also use this feature with the regular Airlock 2FA app. Then there's a new feature. It's called QR Easy Scan or Push to Open App. It's if you're using online QR code login, you can, if enabled in the service settings of the Future A service, you can send a push message to the phone that opens the app already in the mode scanning the QR code. So it's a bit easier for customers to use the online QR login. Then the multi-number challenge feature, which was presented just some minutes ago, is also supported by the Airlock 2FA app. Then there is a security feature called payload encryption, which is also supported by the Airlock 2FA app. I would like to refer to the documentation for details on this feature. There is also adaptive recovery, which can protect the recovery process by introducing some information on your environment and make it more secure. The user verification override feature allows end users to disable or enable user verification in the app itself. This is only possible if you allow to do then this in the Airlock 2FA settings in the future account. Last but not least, there are some in-app security features that make the app itself more secure.
Thanks, Mark, for the introduction and overview over all these new Airlock 2FA features. And let's stick to the topic Airlock 2FA. I have some more. It's about cooldown period and one device. Cooldown period is a fraud prevention method where a newly registered device is put in cooldown for a time period. Normally this is 12 hours, but it's configurable so you can set whatever time frame you want. These 12 hours give the user time to react to an illegally registered device. And during the period, that device that is still in cooldown may be used actually, but it should only be used for low risk actions. For example, transaction approval for low value transactions like less than $80, or maybe for authentication, but it should not be used for high risk transactions like transaction approval above $80 or changing of context data items of communication channels like email or phone number changes. In certain areas, this is a legal requirement, for example, in Singapore. Then we have one device. One device allows you to enforce that a user at any given time only has one device simultaneously. And of course, this can be combined with cooldown period, and there is certain combinations that are quite interesting, and I'll show you how you can actually support both of these combinations. The first one is what I call lenient. So it's actually easy on the user. You have from left to right the time axis, and you see that there is a token 1 in green, it's valid. So there is a new token registration happening, the user adding a new mobile phone, and immediately we're sending an event notifications about the new device. And now we're in this pink period, the cooldown period, and the token 2 is in cooldown, meaning that if we're having token usage during the cooldown period, the token 2 can only be used for low risk transactions, but token 1 is still valid, so it can be used for everything. We're also issuing an event notification, just allowing you to inform the user that a device is still in cooldown during this time period. If after a certain time cooldown period is over, we see another token usage, then we can enforce the one device strategy. This will delete token number 1, and an event notification about the device deletion will be sent. Token 2 is now fully valid, and it can be used by the end user to do whatever actions he needs to take. So in this scenario, the user always has never more than one active device. Additional devices are possible, however, if they are in cooldown. So actually, we see here he has 2 devices, but since one is in cooldown, it's okay. That's one use case scenario. The other use case scenario is what I call strict. And you can see already the green arrow is much shorter. So it ends at the token registration and the event notification that there is a new device. Token registration means there is a new token in town, it's in cooldown period, so we have the pink area, but the token 1 is immediately deleted and the event notification of the device deletion is also sent out immediately with the token registration. If we're using the token during the time period, then the event notification device in cooldown makes probably a lot more sense, because you now can tell the user, hey, you're using a device that's in cooldown, and that's why we're not getting access to the full functionality. Once we're out of cooldown period, then token 2 is valid. Token 1 was already deleted a long time ago. In a nutshell, in this scenario, the user really never has more than one device, and we don't care on whether the other devices are in cooldown or not. So how do you configure that? The configuration is actually very simple. In the Airlock 2FA settings, you define the time period for the cooldown period. Here the example says 12 hours, but it could be 24 hours or just 3 minutes, whatever you deem appropriate for your setting. And on every single authentication and verification step, there is a new checkbox, which is respect cooldown period. We actually have pre-configured all these steps for you with a config migration so that as soon as you decide to add a cooldown period time, all these steps will respect the cooldown period. If there is no cooldown period time defined, then cooldown is disabled and whatever we have on the step really doesn't make any difference. How do you configure the one device? Well, one device, it's a step of its own. You have to configure or add this step into, say, your authentication flow. It should be added right in front of the Airlock 2FA authentication step. And you can set a policy on this step, devices to delete. There's a range of options that you have. And if you do select all devices except most recently registered, then this will delete everything but the most recently registered. And since you can also respect the cooldown period on this step, this will then work in harmony with cooldown period and one device. So that's it finally for everything about Airlock 2FA. Let's start with OpenID Connect and OAuth features. As you can see, it's quite a list that we've added. And the first one I would like to talk about is the consent persister. During the authorization code flow, you're pushed into an authentication flow, and that has a step called the local consent step. This one will expose such a screen to your end users, and they can check or not check which of the scopes that are willing to grant or which they want to deny. Now, in the past, we have not persisted that, and that's what's changed. Now we're actually writing this into the database, and the next time the same user goes through the authentication flow, we're reading this state from the database, and we're pre-selecting everything in the local consent step as it has been during the last run. So you can see here, authenticated. This was pre-selected because it was selected before. Another scope is not selected. For both, we have the date of consent or denial, and it also says that previously granted, previously denied. And we can also show a new scope. There's yet another scope that I have depicted in this sample screenshot. Very important to know, the consent page is skipped if there are no consent changes. So if this time I say grant access and the next time I return and it's exactly the same as it was this time, then the whole page will be omitted. There's self-services for the end user. There is the OAuth 2.0 consent management, and in that screen, the user can grant and deny scopes as he sees fit. He can also delete all the consent. If the user does that, please be aware. Then the next time he goes through the authorization code flow and the authentication flow, he will again enter the local consent step because it will be deleted from the persistency, and then he needs to grant or deny the scopes again. The administrator can also support the end user by deleting the consents for him. We see that down here. You have to delete on the individual consents, or you can delete them all. There is no way for the administrator to grant scopes or to deny scopes. This is something that the user has to do themselves because it's their consent that we're actually persisting in the database. For the configuration in the OAuth 2 local consent step, you can either enable or disable consent storage. And if you want to enable it, then in the authorization server, you have to configure a consent storage repository. Very important, persistent consents require a database schema change. So without the database schema change, this will not be usable by you. For persistent consents, there is an additional feature that we deemed very important, and that's filtering. Not all consents need to be shown to end users, and that's exactly what the always granted scopes on the static client here will do. If you configure a list of always granted scopes, then those scopes will be processed like normal scopes, but in the local consent step, they will not be shown to the end user, regardless whatever else happens around these scopes. The same thing can be configured on the authorization server directly in the authorization code grant. There's the second list. This list is applicable to all the clients, where the first list is applicable only to this particular client. So that's it for persistent consent. Let's move on to a feature that's called pushed authorization requests. This is part of FOPI support, so financial grade API. It's a purely security feature. End users will not notice that this feature is actually being used or if it's not being used. So it's an improvement. It's part of the FOPI standard, and the way it improves security, it does so when you start an authorization code flow. Instead of giving a very long URL to the browser to connect to the authorization server, all the request parameters on the browser URL, you actually have the client first call the authorization server. It must do so authenticated, and then push all the authorization request parameters to the authorization server. So IAM supports both authorization server and client sides. And again, this requires a DB schema upgrade. Now let's see how it works in detail. What we see here is the user agent wants the client to access something. Client knows, oh, I have to run an authorization code flow, and I'm using pushed authorization requests. So what it does is the first request to the authorization server is actually post to the /par endpoint. And here we see response type, client ID, and so forth, all the parameters that this authorization request is going to have. The authorization server validates the requests and stores it. It returns a URL, and the URL has a unique identifier in it, this XYZ, that allows it to identify the parameters once the user agent returns. Client has received that, now redirects the user agent to exactly that URL, the XYZ URL. And now the authorization server can retrieve the original request parameters and handle it like a normal auth request. So I'm not going to show the end of the rest of the authorization code flow here, because now it continues normally as if we had started with a URL that contained all the request parameters, just a little bit more secure. Very important, push authorization requests are on the database, and you need to schedule deletion of expired requests. How do you do that? Well, let's look at the configuration. First, what you need to do is you need to configure a plugin in the authorization code hybrid flow. That's the OAuth 2.0 pushed authorization request. And in there, the really important thing is you need to configure the OAuth 2.0 par repository, the one that requires the DB schema change. For the deletion of those requests, the OAuth 2.0 cleanup task has been enhanced. It now also supports a checkbox cleanup pushed authorization requests, which you should turn on if you intend to use PAR. Now, this was the authorization server side. Let's look at it on the OAuth or OpenID Connect client side. So IAM as OAuth client can use pushed authorization requests, and for that you need in the flow client to configure the endpoint URL of the authorization server. Or in OpenID Connect case, it's automatically configured because from the discovery endpoint, we receive enough information whether PAR is supported by the OP or not, and if it's supported, it will be used. So this is basically hands-off configuration as much as we can achieve it. The next topic is about private key jobs. Again, a FOPI topic, so it's about security. It's about the way an OAuth client can authenticate. So it's an additional OAuth 2.0 client authentication option, and it, of course, part of the FOPI standard. It improves the security by using asymmetric encryption instead of client ID and client secret, which really corresponds to username and password. So how it works is very easy. The client generates a signed JOT token. The JOT is along with the /authorize or /par request, and the authorization server verifies the signature on the JOT to determine of whether it's the correct client or not. IAM supports this for static clients only, and it supports both the configuration of a JWKS URL or the configuration of public keys directly. Again, this feature requires a DB schema upgrade. I really recommend that you do the DB schema upgrade when you upgrade to IAM 8.3. How do you configure it? Well, on the static client, you see these two options. The first one is the JWKS settings. In the JWKS settings, the most important thing is that you have to configure the URL and you have to configure the HTTP client to actually connect to the point where the client has their public key stored. So there, a JWKS document is retrieved from that URL, and IAM will use the public keys contained therein for validating the JOT token signed by the client. The other method is that you directly configure public keys. There is a list there. You can configure multiple of those. If you have more than one, the key ID is mandatory so that IAM actually knows which public key to use. So that's it for private key JOTs. Continuing with PXE, we're supporting PXE in IAM already since quite a while, but we didn't have it for IAM as an OAuth client, and that's what we're now adding with 8.3. For IAM as an OAuth client, you need to configure it in the Flow client. The PXE challenge method has been to be set as something other than none, and then this PXE challenge method will be used. For the OIDC discovery Flow client, it's a lot simpler because we're directly reading the information from the discovery endpoint, and if the OP supports PXE, then we'll actually also use it. Now, this is not a standards feature, but I still hope that this will help a lot of our customers because it's a convenience feature that should allow you to reduce the number of authorization servers if you have multiple configured. It's about client-specific configuration, so-called client overrides. What I'm showing here is an authorization server with all of its default configuration. So basically, this authorization server has everything in it, what the access token looks like, the ID token, what kind of scopes are permitted, and so forth. Now, the new thing is that client-specific, so on the static client, you can configure overrides for scopes, PXE, tokens, and flow settings. So, and you can do that for all the different clients, and this is where actually the reduction in the number of authorization servers should come in. Instead of having to configure a different authorization server for every client, you should be able to combine them back into one single server. Let's look at the details. What can you actually achieve with the configuration of client overrides in scopes and scope policy? You can define scope filtering, client-specific allowed scopes, and also the allowed granted scopes. These are the ones that we just met when we talked about persistent consent. The use of PXE can be configured. For example, you could have 20 clients and one of them is not able to support PXE. Then you can go ahead on the authorization server, you say, yeah, PXE is mandatory. And on the individual client that doesn't support it, you override it by saying, yeah, no, this client doesn't have to use it, and it will work without PXE. In the authentication settings, you can set client-specific authentication methods. So some clients may continue to use client ID, client secret, others could be using private key JOTs. The content of claims in tokens could be changed. You could have overrides for custom and distributed claims for both access and ID tokens. And the access token, you can also override the audience so that it becomes client-specific. And last but not least, you can configure flow settings. So basically per client, you can select what target application is being used. You can do that directly or through ACR values. And by selecting the target application, you can also select a different authentication flow and different identity propagation, which is very neat. All of that only works for static clients for the time being. The last topic in OAuth and OpenID Connect hopefully is also going to be very useful for you. And it's about the content of tokens that we're issuing. We've already supported context data string custom claims. So you could add claims from context data. You can add claims from session ID and client ID. And there's two new things. The string value provider custom claim now allows you to configure a HTTP request value provider. So basically you can add any type of HTTP header that came with the request as a claim to your ID or access token. And even more important is the string from map value provider, because it allows you to configure maps and take single values from those maps and add them as values into claims. So there's the user identity map, which not only allows you to add the user ID, but also provided user ID and other information. Authentication data map will give you information about the factors used during authentication. Roles provider, including tags propagation, allows you to add roles and tags to as claims. And script execution result value map provider will take exactly that, the result of a scriptable step, and add it as claims to your ID or access token. And there are many more, but I don't want to continue with that. You can go to the config editor and look it up yourself. Just remember string value provider custom claim plugin and string from map value provider plugin. Those are the important ones if you want to get at all the detailed maps and value providers that we have in Airlock IAM. So that's it for OAuth and OpenID Connect. Now we're looking at two showcases that we've added to the documentation for the Scriptable Flow Step. The first showcase is a feature that we had with the JSP login app still, but we didn't add it to the new login app UI. And we figured that it might be interesting to show on how this actually can be achieved with a scriptable step. What's the goal here? Well, we want to restrict access to client IPs that we have stored per user. So your user is only allowed to log in if the client IP matches something that we have stored on the user account. How do we implement that? Well, we store the client IPs in context data. We use the scriptable step to validate this client IP, and we use a failing step to enforce the valid client IP. As a picture, we have the authentication flow going from top to bottom, and we have the scriptable step here. And it injects client IP from the HTTP request. It injects allowed IPs from the user database, from context data. And when that evaluation is done, the auth flow session continues, and we have a failing step that has a skip condition on it. If IP in range says yes, then the skip condition matches, so the failing step is not executed. If IP in range is no, then the failing step is executed and the flow is aborted. And this way, we have user-specific IP address filter with just configuration of a scriptable step. You find all the details on this in the IAM documentation. It also tells you on how to add the necessary libraries to Lua and everything else needed to make this script work. The second example I have with me is have I been pawned password check. We've been asked several times that we should add that, and we were reluctant because have I been pawned is actually an API where you need a subscription. And we didn't want to add code into our IAM where we had such a requirement. So what we decided to do is we decided to implement a showcase as a scriptable step. So the goal is that we want to check user passwords against have I been pawned, and if a password appears in a breach, then we want to force a password change. The implementation is we use the scriptable step to hash the password, we call have I been pawned.com, and we process the result. We raise a password change red flag if necessary. So again, here the skip condition is based on the output of the scriptable step. So the picture, authentication flow, the first thing is the password check step. So where we need to get the password from, then we have the scriptable step. It takes the password, hashes it, sends a part of the SHA-1 hash to have I been pawned, receives the result back and processes the output. And then, if necessary, we'll raise the red flag step by checking the script output. If the red flag has been raised, then the mandatory password change step is executed, and we have achieved exactly the desired result. No breached passwords are still in our user database. Again, you'll find all the details in the IAM documentation, so make sure that you look it up. It should be easy to use in your installation if you want to take advantage of the have I been pawned password check feature. Event notifications is something else where we have a lot of customers that really seem to like it. And we've improved it again. What we did this time is that in the event subscribers, we added additional filters on flow and steps. How does it work? So we have here an OAuth flow A and an Airlock 2FE device activated event that writes on the event bus. We have the process event, Airlock 2FA device activated event subscriber that will send an email if such an event device activation has been detected. We also have a second flow that does the same thing. It also executes an Airlock 2FA device activation event. So how do we make sure that only one of the two flows will actually create an event subscriber? That's easily done. We can, with the new filters, we can filter for the flow ID and they're different, A and B. And with that, we can decide on whether the event subscriber for A should be reacting on A or it should only be reacting on B. What do we get with that? Well, we have more control in event subscribers. We can send different messages, or we can even use different channels for the same event type. So flow A could actually have their message, flow B could have a different message. And we can filter on flow ID, step ID, and even flow type. So you could actually have an event subscriber that only reacts on authentication flows, but not on protected self-service flows. Last but not least, has nothing to do with the flow step filter for event subscribers. There's a new event that we've added. It will trigger when user roles have been changed. And that's it from my side. I'll hand back to Mark. And Mark will continue with various features.
I would like to give you some more information about some various smaller features that are worth noting in Airlock IAM 8.3. We start with the correlation ID feature. The correlation ID feature is here to make it possible to correlate logs across all involved systems. Let's explain that using an example. So on the left, we have some HTTP request from a browser or for mobile or whatever. Let's say it's a password check request and it is sent to whatever gateway, ingress controller, or load balancer you have in front of Airlock IAM. Then this gateway or whatever reverse proxy it is, it can add a so-called correlation ID to the request. This is typically an HTTP header. It doesn't really have to be named X correlation ID, but it's some kind of pseudo standard. In this example, the value is 42. And so the request that is sent to Airlock IAM contains this header. Now, the feature allows Airlock IAM to extract this header and use it twofold. Once it is then also logged in the structured log files. And second, it is also sent to backends. So, for example, if we call an SMS gateway or some other HTTP-based backend, then Airlock IAM is going to add this header. So the backend can also log it. If all the systems log the same correlation ID now, it is a lot more easy to correlate different log files from different systems. The JWKS endpoint is new in Airlock IAM, and it's an endpoint that provides all public keys used for verifying JOTIs issued by IAM. If I say all public keys, then it's not only about OpenID Connect and OAuth, it's also about JOTIs issued, for example, in an identity propagator. This simplifies verifying the JOTIs signatures a lot, especially when you're rolling over keys. It can be configured in the login app in the advanced settings section. Two more notable features. So if you know the device token feature, then it's good to know that device token registration is now also available as flow step for authentication flows and protected self-service flows. Then on the REST APIs, on the login REST API, All the retrieve calls are now no more necessary. So they're still supported, of course, so you don't have to change any of the REST clients, but you can also piggyback this information in other responses. So you need less round trips for the login up UI and other REST clients, which makes it more performant. Then, as a reminder, as already communicated in the last 2 releases, we moved from Docker to Quay. So our images, they are no longer on Docker, but they are now on Quay. So who affects this? It's customers that had access to our Docker Hub repository. If you haven't changed that yet, you need to do something now. The whole tech zone stuff where you can download releases and also Docker images remains unchanged. So when is this going to happen? It's going to happen now. We started in April and we will cease to provide images to Docker Hub with this release this fall. What do you have to do if you have not done this yet? Then you should create a QA.io account, which is a Red Hat account, and then create an Airlock support case to tell us your account. You will then receive an invitation from QA.io, and if you accept this invitation, then you get access to the registry. Last but not least, some technical information on the release. So the most important thing probably is how to upgrade. The release is minor, it's non-breaking. Therefore, if you're not using new features, then you don't have to do anything manually. You should be able to just update. However, you need to upgrade the database schema if using the new OpenID Connect FAPI related features like private key jotties and so on. But we recommend upgrading the database anyway, so you stay on top of the latest database schema. It may make future updates or fixes a lot easier for you. How to upgrade? I would like to refer to the documentation to chapter 6.5. Then some technical data on the release. It will be supported for 21 months, as always. And it's an LTS, a long-term support release. It's a minor release. And you'll find the documentation as usual under docs.airlock.com/IAM/8.3/latest will also work. And you find information on the Academy if interested in trainings or certifications on www.airlock.com/academy. Then be aware that support for 8.0 ends in end of January 2025 and 8.1 ends in June 2025. 8.2 will end in January 2026. So the next release, we call it 2025 Spring. It's probably going to be 8.4 or 8.5. We don't know that yet. Is planned for end of March or beginning of April 2025. So with that, I would like to thank you and hope you enjoyed our release video and got some interesting information from it. Bye-bye.